Okay, so this is the last lesson in nuclear, lesson 4, and we're going to focus on the difference between natural versus artificial transmutation and fusion versus fission. Before I go over these, I would actually like you to pause the video and read through pages 14 through 17 because I'm just going to hit the highlights of what I actually want you to remember. So do that now and then continue the video. So just to review, transmutation is when an element turns into a new element. And there's two ways that this can happen. One is natural decay, because you're starting with an unstable nucleus, so it automatically or spontaneously releases a nuclear particle and turns into a new element. So as you can see here on the left, this is an example of nuclear decay. Notice how we're only starting with one element, and then we have our yield sign, and then our nuclear particle. Unlike artificial transmutation starts with something that is stable versus unstable. Therefore, we have to bombard the nucleus with some type of particle to make it unstable. And then the new element is created. So here we have two reactants. We have the stable particle and what we bombarded the nucleus with. Whereas in natural, it's already unstable, it doesn't need any help, so it automatically decays. So just to review, in natural, we start with something unstable. Spontaneous decay, mean it happens by itself. New element. In artificial, we start with a stable nucleus, bombard the nucleus, and then new element. I also like to say this has one reactant, this has two reactants. So let's review fission versus fusion. Remember, I like to say fission equals division. We start with something large and we turn it into something smaller. So in this case, we're starting with the U-235, right? And we're going to turn it into krypton and barium. In fusion, fusion means unite, and that's where we take something smaller and we turn it into something larger. So we're always going to start with hydrogen and we're always going to form helium. We might start with deuterium, which is H2, or we might start with a tritium, H3, and a regular hydrogen, but it's the conversion of hydrogen into helium. Now, both of these produce, okay, lots of amount of energy. Fusion is more energy than fission. But in both cases, some of the mass, a small amount of that mass, has been converted into a whole lot of energy. Now, there's some other things that are nice. They may ask you on the regions, like what is a benefit to fusion over fission, and basically it's cleaner, essentially no radioactive waste compared to radioactive waste in nuclear fission. They might want to know what are some of the concerns about nuclear fission. You could have a nuclear disaster if a nuclear power plant explodes. The storage of radioactive waste, you can have problems with seepage, lots of things like that. And those are basically the things that I wanted you to take away from this last lesson.